In today's lesson, we'll be learning how to convert standard form to factored form with a focus on decomposition. In a previous lesson, we learned that you can convert factored form to standard form by expanding. You can also change standard form back to factored form using factoring. A type of factoring is decomposition. In today's example, we'll be changing standard form back to factored form using factoring. More specifically, we'll be using decomposition. Decomposition is used when A does not equal to 1. What exactly does that mean? Well, A is not 1. It's actually 3. That means we can use decomposition here. Let's begin by looking at A and C. But what exactly is A and C? Well, A is 3, so I'm going to write that right over here. And C is -7, and I'm going to write that right over here. This looks like 3 subtract 7, but there's actually a hidden multiplication sign between these numbers. So 3 multiplied by -7 gives you -21. Next, let's take a look at B. Well, B happens to be +4. So I'm going to write +4 right over here. Using guess and check, we have to find two numbers that multiply to give us -21, and the same numbers must add up to give us 4. I'm going to start with -7 and +3. -7 times +3 will give us -21. So that definitely works. However, -7 plus 3 gives us -4. So that doesn't work. Let's try something similar. Let's try +7 and -3 instead. So 7 multiplied by -3 gives us -21. So that works. Next, let's do +7 plus -3. And that gives us +4. So that works as well. If you remember, this process is called decomposition. We're now going to decompose the center term, +4x. In other words, we're going to break it down into smaller pieces. I'm going to break it down into +7x and -3x. You might be wondering where I got these numbers from. Well, I got the +7 from here and the -3 from here. Everything else is going to stay the same. The y is going to stay the same. The equal stays the same. The 3x to the power of 2 stays the same. And the -7 at the end stays the same. As you can see here, I've decomposed the center term +4x into -3x and +7x. You'll notice that these terms have switched places from the previous slide. The order of these two terms doesn't actually matter. Let's break these 4 terms into 2 smaller groups. Right now, I only want you to focus on these 2 terms. We're going to find the greatest common factor of the coefficients. The coefficient here is 3, and the coefficient here is 3 as well. The greatest common factor of 3 and 3 happens to be 3. Next, we want to find a common variable with the lowest exponent. They both have the variable of x, and the smallest exponent happens to be an invisible 1. So I'm going to write x to the power of 1. And down here, I'm going to combine 3 and x to the power of 1. 3x to the power of 1 is going to be written over here, and I'm going to place those original 2 terms into brackets. Everything inside the bracket is going to get divided by 3x to the power of 1. 3x to the power of 1 is going to stay the same, and the brackets are going to stay the same as well. Since we are dividing terms, that means we're going to be using the quotient rule. Coefficients are going to get divided. So 3 divided by 3 is going to give you 1. Next, bases stay the same. So that variable of x is going to stay the same. And last, exponents get subtracted. So 2 subtract 1 gives you 1. Let's repeat this process all over again. Coefficients are going to get divided. So negative 3 divided by 3 gives you negative 1. Next, take a look at the bases. Bases stay the same. So that variable of x is going to stay the same. And last, exponents get subtracted. So you have a hidden 1, subtract 1, which actually gives you 0. We can definitely clean this up. I'm going to remove the exponents of 1 here, the exponent of 1 here as well. I'm going to remove this coefficient of 1, and I'm going to remove x to the power of 0 because anything to the power of 0 kind of disappears. Let's take a look at these two terms right now. We're going to begin by finding the greatest common factor of the coefficients. So the greatest common factor of 7 and 7 happens to be 7. Next, we want to see if there's a common variable with the lowest exponent. Well, we have a variable here, but we do not have a variable over there. So they don't have a variable in common. So our combined common factor is just going to be 7. I'm going to write my 7 over here, and I'm going to add a positive sign in front of it since it is positive 7. In brackets, I'm going to rewrite what I originally have, which was 7x subtract 7. And then everything inside the brackets is going to get divided by 7. The positive 7 is going to stay the same, and our brackets are going to remain as well. And since we are dividing terms, we'll need to use the quotient rule once again. Coefficients are going to get divided, so 7 divided by 7 is going to give you 1. Next, bases are going to stay the same, so that variable of x is going to stay the same. And then exponents get subtracted. We have a hidden 1 over here, and we have no exponent in the bottom. So 1 subtract nothing is going to just stay 1. And last but not least, over here we have negative 7, and 7 is coefficient, so we're going to divide them, and that is going to give you negative 1. We can definitely clean this up by removing this exponent of 1 and this coefficient of 1. At this point, I want you to think of everything highlighted in yellow belonging to one group and everything highlighted in orange belonging to another group. What does this group have in common with this group? You may have noticed that x minus 1 in brackets appears in both groups. So we're going to rewrite this y, nothing has happened to it, nothing has happened to the equal sign, and the x minus 1 in brackets, we're going to rewrite it over here. And then I'm going to take this leftover 3x and this leftover positive 7, and I'm going to put them in their own set of brackets. In conclusion, we've just converted standard form to factored form using decomposition.